Okay, so this is question 3 from 2010 based on rates of reaction experiment. This experiment is the one that we did where we add hydrochloric acid to sodium thiosulfate, put it on top of an X on a piece of white paper or on a white tile, and after a while the solution becomes opaque, okay, or you're not able to see the X through it anymore. When the X disappears, that is when your reaction has occurred. Okay, so that is our question. They go through the procedure that they found the reciprocal of the time, which is the rate, okay, and then that they carried it out at different concentrations. Okay, so it says identify the precipitate produced in each flask. That precipitate is sulfur. Okay, so we remember from when we did that experiment that the solution turned a yellow color. That's why we couldn't see the X anymore, and that is because sulfur was produced, and we couldn't see through the yellow, we couldn't see through the sulfur. Okay, so sulfur is what's produced. Describe a procedure for diluting the 0.2 molar thiosulfate solution. Okay, so we measure 30 centimeters cubed of the 0.2 molar, and we dilute it to make up to 50 centimeters cubed using deionized water. So that's just making up solutions. Okay, we should be okay with that at this point. Now, okay, so part C then, why are the concentration and the volume of the hydrochloric acid kept constant? That is so we only have one variable changing. Okay, if we had more than one variable changing, we wouldn't know if it's the concentration of the sodium thiosulfate that was causing the rate of reaction to change or not. Okay, we wouldn't be sure. Okay, so that is that's that. Okay, so only one variable is changed. Okay, part D then is the part that we are going to concentrate on for the most part in this video. Okay, so plot a graph of the reaction rate 1 over time versus concentration of sodium thiosulfate, and what conclusion can be drawn from the shape of the graph about their relationship. Okay, so we're going to plot this. So we have concentration along the x-axis, rate, which is 1 over t, along the y. So what I'm going to do first is I'm actually going just at the moment to cross these out, just so we don't take the wrong figures, because it can get a little bit confusing maybe for some people. Alright, so just cross them out for now. Okay, so our first point is 0.2, 0.88. So 0.2 is over here on the right hand side. We're going to go up to 0.88, which is going to be almost 0.9. Okay, and of course yours would be more accurate on a piece of graph paper with your pencil than I suppose digitally on here. Okay, then your next point is 0.16 and 0.7 there. Okay, and when we have all our points plotted like so down along, just get rid of that little dot. Alright, we take out our ruler and we're going to draw a line of best fit. Okay, so we're going to try and get as close to as many of the points as possible. So it's going to be about there. Okay, and then we draw our line. Okay. Now, okay, so that is our line. So you get points for plotting your points, for your axis, and for the actual drawing of your line as well. Okay, and what conclusion can from the graph about the relationship between the rate of reaction and the concentration? Okay, because it's a linear graph, because it's a straight line, we can say that they are directly proportional. Then the next part of the question, use your graph to predict the time taken for 50 centimeters cubed of 0.1 molar solution of a sodium thiosulfate to react with 10 centimeters cubed of hydrochloric acid. So what we're going to do here is you go to point 1 on your concentration for sodium thiosulfate. Get my ruler to spin around. There we go. Alright, go to point 1. And we draw a straight line up from the point 1. So we meet our graphed line. Then, then wherever that meets, we just go straight across. Okay, and across. Okay, and read whatever that figure is. Okay, so we have at 0.1 molar, our 1 over T is equal to 0.43. Okay, to find our T, we're going to put 1 over that number again. 1 over 0.43. Which gives us an answer of, it should be 2.3 something, I think. 2.32 or 2.33. Okay, and that is your time. Okay, that's your answer for part E. For F then, the procedure described above is repeated using those portions at different temperatures. Okay, would you expect the rate of reaction to increase or decrease or stay the same as temperature increased? Okay, so you would expect that the rate of reaction, or sorry, not the rate, but the reaction time would decrease. Okay, so your reaction time would decrease because more particles would reach your activation energy, so more effective collisions would take place. So the reaction would happen quicker, so therefore your time for the reaction decreases. Okay, and that is 2010 question 3.